a body of mass 0.25 kg is shot straight up into the air with a velocity of 25 meters per second, what is the maximum height attained by the body? So what we are going to do first is to show that it is shot up in the air. So the body was initially here, the height 1 here is 0, while the velocity, initial velocity is 25 meters per second. So at a later time it is here. So the mass, the weight will act downward, and here the final height is what we are looking for. And of course we know that the velocity at maximum height is 0, and we have ignored an upward force, that something like a resistance, drag, and what have you. So it's 0. So let us start. It means that the distance between here and here is y, if you like, y1 minus y2, and this will give us negative. But if it's fallen, we can say it is y2 minus y1, but since it's going this way, we can say y1 minus y2, because we want to get the work done. So the displacement, the direction of fall due to gravity and the displacement are oppositely directed, so the work done is going to be negative. So that is how we're going to do it. So let's say the work done due to gravity is equal to the weight, that force, times the displacement, and that will give us a mg times y1 minus y2. So we will now see that we will have it to be equal to, that's wg, let me just write it this way, is equal to mg y1 minus mg y2, or you can just say it's u1 minus u2. So we find out that here y1 is 0, and at the maximum height it is something. So it is wg is equal to 0 minus mg y2. So let's keep it and look at the other thing. You know that if the only force acting on this is gravitational force, this downward force, there is no force, no other force except this gravitational force, we can check out the work done using the work energy theorem. And that total work done using work energy theorem is just changing kinetic energy, that's K2 minus K1. So we'll find that the total work done will be half mv2 squared minus half mv1 squared. So that you see also that from here the maximum velocity is 0, so everything here is 0 minus half mv1 squared. So what we are now going to do is to equate the work done by kinetic theory and the work done using potential energy. So if we equate them, because of course this is a total work, because there's no other force acting on this except that of gravity. So if we equate the two, we'll have that wg is equal to, if you like, w dot, and that is minus, this implies that minus half, okay, minus half mv1 squared is equal to minus mgy squared. This one is this one is this. So that mass will cancel mass, and minus will cancel minus. You have that y2, not y squared, is equal to v1 squared over 2 times g, and that is 25 times 25 all over 2 times 9.8 meters per second square. This is in meters, so you have it to be approximately 31.9 meters. So what we have just done is to use the sum K plus U is equal to E, where E is the total mechanical energy of the system. The system here is the mass and the earth that is causing the gravity. So, and this is law of conservation. What we have used is that K1 plus U1 is equal to K2 plus U2 and is equal to constant. So that here is half mv1 squared plus mgy1 is equal to half mv2 squared plus mgy2. So you see that here is 0 and here is 0. So we put it this and this to get this. Another thing that we would have used is to use, if we are not solving it through this method of energy conservation, we can use the formula V squared is equal to U squared plus 2AS, where this is the final velocity, initial velocity, and the acceleration due to gravity. A is equal to minus G and V is equal to 0 at maximum height. So we have that 0 is equal to U squared minus 2GS, and the S is our Y. S is our Y2. So that we have that Y2 is equal to U squared over 2G. That is if we use equations of motion. And what this thing means is that this height is independent of mass. To find this height is independent of mass. And you see that they look alike. V1 is the initial velocity. So that is how to solve it. Please subscribe and like the video. Thanks and bye.